Okay, so now we're moving on to volume of cones. So name and date at the top. We're doing, yep, just cones. We moved on from cylinders to cones. So these are sugar type cones. We've got some cones here at Disney World. How much stuff can they hold on the inside? So what we would do in class is I would show you that I would take this cylinder and I would take its cone and fill it up with rice and figure out how many cones fit inside the cylinder, and it would be 3. So yesterday we learned that the volume of a cylinder is pi r squared h. So this one is going to be 1/3 pi r squared h, just like when we worked with pyramids and, when we worked with pyramids. And that would have been a last year thing. But we also talked about it last week. So a cone, here's a vocab word, pause me when you need to. A cone is a 3D figure with one circular base connected by a curved surface to a single vertex. One circle, one point, kind of like a pyramid. So if we look at this little stop and reflect, it says these two people are simplifying pi times phi squared. Dario rounds pi to 3.14, and Dario uses the pi key on a calculator. Which student calculation is more exact? And it would be whoever uses the pi button, because rounding is rounding. It's not exact. So the formula, I'd like you to write it every time. You can either pick one of these, but I'm going to choose 1/3 pi r squared h because it tells me I need pi, I need radius, and I need height. Plug, chug, check your label. Just like yesterday. It's very similar. So we're going to find the volume of these cones. I'm going to use the pi button today. So volume equals 1/3 pi r squared h. And the 1/3 is a little goofy. So I type all of this in, and then I take my answer divided by 3. So maybe a better way to write this would actually be to do pi r squared h all over 3. So when we use the pi button, the radius they gave me of 2, the height they gave me is 7. That's next to the perpendicular box, so that helps. Then I'm going to take that answer divided by 3. So I'm going to do pi 2 squared times 7, and that's that nasty number. I'm going to round it here. It says round to the nearest tenth. I'm going to leave it in my calculator, but I'm going to round it. Oh, that would actually be 88 rounded to the nearest tenth. But then I'm going to take that divided by 3 and round my final answer to 29.3. So the volume of this cone is 29.3 feet cubed. Okay, this one's on its side, so here is some help to talk about this. Oh, the whole length is 24, so that's going to be the diameter, and the height is 26. So the radius is going to be 12, so make sure we have all the things we need. So volume equals pi r squared h divided by 3, or 1/3 pi r squared h, however you want to write it. Pi, the radius is 12, so 12 squared times 26. Then we're going to take that divided by 3. So, and actually 26 is divisible by 3. No, it's not. Just kidding. I don't know why I thought that. Okay, so taking the top, pi 12 squared times 26 is 11762.1, but I'm actually going to leave that in my calculator. And take that divided by 3, and I end up that the volume is 3,920.7 millimeters cubed. So there's 2 picture problems. Take in what you know and plug and chug. Here's some in words. So it says a cone-shaped paper cup is filled with water. The height of the cup is 10 centimeters. There's our height, our h, and the diameter is 8. So that means that we need the radius to be half that, 4 centimeters. What is the volume of the paper cup? So volume equals, I'm going to rewrite it a little bit different so that we see that we can practice both ways. 1/3, but my process is going to be the same, pi 4 squared, height 10. So I'm going to type this part in my calculator, and then I'm just going to divide by 3. So pi 4 squared times 10, I'm going to take that answer, divided by 3. 167.6. The volume of this is 167.6 centimeters cubed. So this one's a little bit tricky. So it says April is filling 6 identical cones for her piñata. Each cone has a radius of 1.5 inches and a height of 9 inches. What is the total volume of the cones? Rounded nearest tenth. Okay, so volume is 1/3 pi r squared h. So I can take my stuff and plug it in, pi. The radius was 1.5. The height is 9. So I can actually 1/3 can go into 9. So I'm going to simplify right here and just change this to a 3. You don't have to. You can do the whole thing and then divide by 3. So this is just pi times 1.5 times, now 3, 14.1. So the volume of one cone is 14.1 inches cubed. But they want of the total volume of the cones, plural. So since there's 6 of them, I need to take my answer. I didn't round it. Times 6, trying to just be exact. 84.8. 0.8 inches cubed. That's the total volume. All right. So we practiced these yesterday. Run a composite solid, include similar to cones. You can find them by decomposing or taking it apart into solids whose volumes you'll know how to find. So add the shapes, or if I take something out, subtract them. Find the volume of the solid. I see a cone and a cone. So a short cone, I'm going to call it a short, plus a tall or long. So both of those are 1/3 pi r squared h. Then we have to do the same thing for the other one. I'm just going to write it both ways so you see it both times. So 1/3 pi, for the short one, the radius is 6. The height is 5.5. For the bottom, they have the same circle, so the radius is going to be the same, 6 squared. The height is different. Okay, so pi 6 squared times 5.5 divided by 3. I'm going to round this one nearest 10th, 207.3. I'm going to add to that whatever I get over here. I'm just going to go up. Pi 6 squared, 13 divided by 3, 490.1. That, and so then I'm going to add those together. 490.1 plus 207.3 is total volume of 697.4 inches cubed. Okay, one more with composite solids. Slide 6. Find the volume of the solid at the right, round nearest 10th. Okay, so I've got a cone. I'm going to add to it a cylinder. So difference formulas. 1/3 pi r squared h plus just pi r squared h. So pi times the radius, so the diameter is 10, so the radius would be 5. The height of the cone, because that distance would go here as well, and I only want half of it, so 5 and 5. The height of the cone is 4. And then I have to take that divided by 3. Plus pi, the radius of the cylinder is the same, 5 squared, and the height of the cylinder is a little different, 3. So pi 5 squared times 4 divided by 3. So cone is 104.7 plus pi 5 squared times 3, 235.6. 104.7 plus 235.6. So the volume of this grain bin, maybe 340.3 centimeters cubed. It would be a tiny grain bin though, so a mouse grain bin. Okay, switching it up a little bit, solving for something other than the volume. So they're going to give us something different. The volume of a cone is, so they're giving you V. So we know that the formula is pi r squared h and then over 3 or divided by 3 or 1/3. And the height is 8. What is the diameter? So not only are they asking for the radius, they want the diameter. So plug in what we know. We know that the volume is 471.24. We know pi is 3.14. We don't know the radius. We know the height is 8, and we know that we have to divide by 3. So in order to get rid of this divide by 3, we would multiply by 3 on both sides. So that'll get rid of that. And then we can take 3 times 471.24. And and we get, I'm going to run out of room, so I'm actually going to go up and over here. So 1,413.72 is equal to, we've got 8 pi and r squared over here. So I'm going to go ahead and rewrite it as 8 pi r squared. Now 8 times pi, I'm going to do that in my calculator, and I get, I'm going to round here to the nearest tenth. Or I could just take this and divide by 8 pi. That would make it a little more exact. So I'm just going to divide both sides by 8 pi. So they'll go over here. So what I'm going to do is I'm going to take 1413.72 divided by 8 pi. And I get 555.2. So the radius squared is equal to 555.2. Now we're at radius squared. So now we have to get the radius by itself, so undo it, so square root. So if I take the square root of this one, so we can do the square root, which is the second button, the x squared button, and then I'm going to take my previous answer that the calculator has stored, so I'm going to push the second button, and I'm going to push the negative button so that it says answer, or I could just type, I could have written that down, 23.6. So the radius is 23.6. Well, to find the diameter, I have to take that times 2, so the diameter is 47.1. And that would just be a regular inches. So that's the diameter. That one's a little bit trickier. A lot of work to go through that one. Another question, or a similar one here. It says find the height of the cone to the nearest tenth. So the cone volume formula is pi r squared h over 3, or 1/3 out in front. We know that the volume is 42.39, so I'm going to actually go to the right so I have room. 42.39 equals, I'm going to rewrite it as 1/3. 1/3 pi r squared, we have that one, so 3 squared times h. And I'm actually going to do all of this in my calculator. So I'm going to do, oh, this is 9. This is just going to work out better if I do 9, 1/3 of 9 is 3. So this is 3 pi. I'll leave it as 3 pi h. And I'm going to divide by 3 pi. So 42.39 divided by 3 pi. Oh, this is, let's put this in parentheses. 4.5. So the height is actually 4.5 meters, and which tells me that this one is incorrect up here. So this number, 1413, 8 pi has to be in parentheses, because otherwise it's going to take 1413 divided by 8, then times pi. So 1413.72 divided by parentheses 8 pi. It's 56.25. That's better. Then the square root of that answer is 7.5. There we go. That times 2 is 15. Got it sorted out. Okay, there we go. That's much better. So, there we have it. Some different types. So we've talked about finding the volume if we're given all the information we need. Now we have solids we can put together, and then sometimes we have to work it backwards. Sometimes you have to give up on people, not because you don't care, but because they don't. Have a great day.